Most organizations say they picked public cloud or hybrid or multi-cloud. They didn't. It happened. One exception, one acquisition, one latency problem, one regulatory memo at a time. And these architectures quietly decide who can ship, who can comply, and who gets blamed when something breaks. This isn't a provider preference. It's an operating model decision with security debt, cost debt, and organizational debt attached. So before anyone argues Azure versus anything else, step back. The real question is, why did this get so confusing in the first place? The foundational misunderstanding, cloud as a place. The foundational mistake is treating cloud like a place, a location, a destination, a box you move things into. It is not. In architectural terms, cloud is an operating model, a control plane that allocates resources, enforces or fails to enforce policy, and bills you for behavior. The data plane is where workloads run. The control plane is where reality gets defined. Most enterprises obsess over the data plane because it feels concrete. Servers, networks, storage, latency. Meanwhile, the control plane quietly becomes the system that decides what allowed even means. That distinction matters because you can't choose public cloud if your control plane doesn't match your organizational intent. You can buy Azure consumption all day and still run like it's 2008, just with different invoices. This is where intent versus configuration starts to matter. Intent is what leadership says in a steering committee. We're going cloud first. We're standardizing. We're reducing risk. We're accelerating delivery. Configuration is what teams actually build when they hit constraints. The old identity stack, the on-prem dependency nobody documented, the third-party vendor that only supports a specific topology, the plant network that can't tolerate a new hop. Intent is a sentence, configuration is the system, and the system always wins. That's why so many cloud debates stay shallow. People argue public versus hybrid as if it's a philosophical identity, but those words are proxies for constraints: sovereignty, latency, licensing, operational maturity, and the reality that policy erodes unless the platform enforces it by design. Here's a concrete example that shows up constantly. An enterprise announces cloud first. The infrastructure teams start migrating workloads. The identity team, usually the last people invited to the celebration, finally maps the trust boundaries. And they find 3 incompatible identity realities operating at once: on-prem Active Directory assumptions, Entra-ID conditional access patterns, and third-party SaaS identity islands with their own rules. Nobody designed that on purpose. It emerged. Now the organization has to answer uncomfortable questions. Which environment is authoritative for access decisions? Where do privileged roles live? What is the break glass model? Which logs are actually complete enough to satisfy audit? This is where hybrid by default begins, not as strategy but as entropy. Because hybrid is often the natural byproduct of organizations trying to reconcile 2 things at the same time: modern control plane capabilities and legacy data plane dependencies. And if they don't reconcile them intentionally, they reconcile them accidentally. Accidental hybrid is what happens when each team solves its own local problem and the enterprise calls the aggregate architecture. The confusion isn't cultural first, it's structural. Cloud platforms, Azure included, scale decisions. They don't scale intent. They scale what you actually configured. That means every exception, every unmanaged subscription, every temporary bypass becomes part of the machine that makes decisions later. Missing policies create obvious gaps. Drifting policies create ambiguity. And ambiguity is the birthplace of incidents. This is also why executives get blindsided. They think they approved a cloud move. What they actually approved is a distributed decision engine that now makes thousands of micro decisions per day about identity, network paths, data access, and spend. When those decisions go wrong, the incident review doesn't blame the cloud. It blames your organization's inability to express intent in enforceable terms. So when someone says, "We should go public cloud," the right response isn't agreement or disagreement. It's, what operating model are you committing to? Who owns the control plane? Who owns policy drift? Who owns cost behavior? And which parts of the business are allowed to stay deterministic versus becoming probabilistic? Because once the control plane becomes the enterprise's nervous system, the debate stops being where do workloads run and becomes how do we keep governance from decaying? And that leads to the next uncomfortable truth. Hybrid wasn't a choice. It was inevitable. Why? Hybrid by default was inevitable. Hybrid shows up in enterprises the same way gravity shows up in physics. You can disagree with it, you can budget against it, you can pretend it's a phase, and then your system drifts back to it anyway. Because hybrid isn't a product choice. It's what happens when an organization has constraints it can't delete. Legacy applications, legacy identity, legacy networks, legacy data, and legacy contracts. Those aren't sentimental artifacts, they're binding agreements with reality. Start with the legacy estate, not just old servers, whole operating assumptions, apps that were built with hard-coded network paths, databases that assume local, low-latency storage. Batch jobs that run fine on-prem but become unpredictable once you add cloud networking and metered services. And then the ugly part, operations. Runbooks written for systems that don't scale, teams organized around ticket queues, and ownership models that assume someone can just log into the box. Public cloud doesn't remove any of that. It just adds a new layer where those assumptions start failing in new and expensive ways. Then you hit regulation and sovereignty. And here's the thing, regulation doesn't care about your architecture diagram. Regulation cares about control, locality, and evidence. You can't talk your way out of where does the data live with a strategy deck. You need provable boundaries. You need logs you can produce. You need identity decisions you can explain to an auditor who does not accept it's in the cloud as an answer. So the organization does what organizations always do under pressure. It keeps certain workloads local. It keeps certain data sets local. It keeps certain keys local. It keeps certain processes local. Not because it loves on-prem, because it loves staying in business. Now add latency and data gravity. Latency is the most honest part of architecture because it ignores your intent. It's physics, and physics wins. If you've got clinical systems, industrial control, point of sale, trading, real-time decisioning, anything where milliseconds translate into risk, then moving compute away from the data isn't modernization. It's adding failure modes. And data gravity is the quiet amplifier. The more data you generate in a location, the more things get pulled toward it. Analytics, inference, integrations, and people making decisions. Moving the workloads becomes expensive. Moving the data becomes impossible. So you stop trying. This is where hybrid becomes not just a compromise, but a placement strategy. Put compute where it needs to be and manage it with a central control plane if you're competent. Now the accelerant nobody plans for. Mergers and acquisitions. Most multi-cloud strategies are not strategies. They are HR events. You buy a company, they arrive with a cloud provider, an identity stack, a network model, and a pile of compliance exceptions that already have executive sponsorship. The fastest path to multi-cloud is acquisition. The second fastest path is a SaaS binge. Neither is architecture. And leadership usually doesn't want to hear, we need 3 years to rationalize this. They want synergy by Q3. So the systems coexist, then they interconnect, then they share identities, then they share data. And now you're not operating a clean architecture. You're operating a stitched ecosystem with new attack paths you did not model. Here's the grounding example that turns hybrid into a board-level discussion. A team migrates a customer-facing service into Azure. It works. Great. Then a dependency shows up. The service must call an on-prem system that wasn't on the migration plan. Performance drops, timeouts increase. The business sees customer impact. Someone says, it's a cloud problem. It's not. It's a distance problem. Then the question becomes, do we move the dependency? Do we replicate the data? Or do we move part of the workload back closer to the dependency? That is hybrid, not ideology. Placement under constraint. So if you're wondering why hybrid by default is so common, the answer is simple. Enterprises don't start with a blank sheet. They start with an estate and a risk model. They inherit constraints faster than they can retire them. And every constraint forces locality decisions that pure public cloud can't satisfy without either extreme redesign or extreme risk tolerance. This is the uncomfortable truth. Hybrid wasn't chosen. It was the only architecture that could survive long enough for the organization to pretend it had a choice. And that's why the next question matters. When you do go public first on Azure, what is it actually excellent at and what does it quietly punish? Public cloud on Azure, where it's actually excellent. Public cloud on Azure is not a morality play. It's a capability accelerator. When it fits, it feels unfair. Teams ship faster, environments appear on demand, and the business stops waiting for infrastructure as a prerequisite to strategy. That's the real value, not that servers are somewhere else, but that the control plane makes provisioning, policy, identity, and managed services consumable at scale. Azure is especially strong when you can actually use it as designed, leaning into managed services instead of recreating your data center with a new billing model. The moment you stop treating Azure as VMs with better branding, you start seeing why public first is attractive. The first place Azure is excellent is global reach with deep managed service coverage, not just regions. A practical menu of services that let teams assemble working systems without building the plumbing. Managed databases, messaging, identity integration, monitoring, security posture tooling, things that would be months of work on-prem become a configuration choice. That doesn't mean easy. It means the complexity moved from construction to consumption, and consumption is faster. The second place Azure is excellent is enterprise identity gravity. This is not marketing, it's history. Most enterprises already have identity processes, directory patterns, and compliance expectations that map more naturally into Microsoft's ecosystem. Entra ID becomes the default decision engine, not because it's perfect, but because it already sits in the blast radius of everything else. Microsoft 365, device management, conditional access patterns, legacy federation, and the organizational muscle memory around it. That distinction matters. In public cloud, identity isn't a feature, it's the control plane's spine. If your organization already treats identity as the first control surface, Azure tends to feel coherent, not simpler, coherent. The third place Azure is excellent is PaaS as velocity, when teams are allowed to consume it without being strangled by internal gatekeeping. App services, managed databases, managed Kubernetes, eventing, analytics. The payoff is fewer things you patch, fewer things you babysit, and fewer things you pretend are standard while they quietly drift. But there's an open loop here, and it matters. PaaS only accelerates you if your operating model supports it. If your platform team designs the environment as a permit office, slow approvals, exceptions as the default, vague standards, then the business won't wait. It will root around you. Shadow subscriptions appear, unmanaged resources proliferate, and the organization returns to the same problem it had on-prem, just faster. So what's the archetype where public-first Azure really wins? A digital retail or consumer services business? Bursty demand, seasonal spikes, marketing campaigns that can't be scheduled around infrastructure windows, teams that release frequently, accept some variability, and value speed over perfect predictability. In that world, the elasticity story is real. Scaling out is cheaper than maintaining permanent capacity. And yes, cost moves around, but leadership accepts it because growth is the goal, not stability theater. Public first also fits organizations with high change velocity and sufficient cloud maturity. They can operate guardrails, tagging, policy, identity, and observability as defaults, not as retrofits. They can treat infrastructure as code, as normal behavior. They can measure cost per transaction or cost per customer and make trade-offs consciously instead of reacting to a monthly invoice like it's weather. Here are the fit signals executives should listen for. First, the organization wants speed, and it's willing to pay for it, not in slogans, in budgets and tolerance for variance. Second, teams can consume managed services without recreating everything as bespoke platforms inside Kubernetes, because portability. If the platform team keeps reinventing services to avoid vendor dependency, it's not building resilience, it's building delay. Third, governance can keep up, not perfect governance, sufficient governance. The ability to set boundaries, see what exists, and enforce intent without human middleware. If those signals are true, public-first Azure is an advantage. It compresses time, it compresses operational burden, it gives leadership a control plane that can be extended and standardized. But the same traits that make public cloud fast also make it unstable. Because Azure will happily let you scale, it will also happily let you sprawl. And that's where the failure modes start. Where pure public, Azure breaks. Here's what most people miss. Public cloud doesn't fail because it can't run your workload. It fails because it changes the economics and the control model under your workload, and your organization keeps operating like nothing changed. The first breakpoint is predictable, always on demand. If a workload runs at a steady baseline 24/7, elasticity isn't a benefit, it's an invoice. You're paying for the privilege of optionality you don't use. And Azure will not tap you on the shoulder and say, hey, you've effectively rebuilt a static data center, but now you rent it by the hour. It will just bill you. This is where leaders get surprised. The business thought cloud meant cheaper. The system delivered cloud as designed, metered consumption with options. But the organization asked for stability, not volatility. Those are different operating models. The second breakpoint is cost visibility decay after year 2. Year 1 is clean. Everything is new, tagged, and still emotionally important. Year 2 is drift. The POC became production. The temporary environment never got deleted. The test clusters kept running. The we'll clean it up later list became the architecture. And because Azure makes provisioning easy, sprawl becomes normalized behavior. This is not a moral failure. It's an entropy law. If creation is cheap and deletion has no owner, the estate grows. Then finance sees a bill that looks like a corporate ransom note and asks, what is all this? The uncomfortable answer is it's your behavior aggregated. The third breakpoint is licensing and entitlements. People love to call this misconfiguration. It's not. It's structural friction. Public cloud works best when identities, licenses, and consumption models line up cleanly. Enterprises don't line up cleanly. They have Windows and SQL entitlements, hybrid benefits, reserved capacity decisions, special licensing terms, and procurement contracts that were negotiated in a different era by different people with different assumptions. So you end up with a cloud that is technically scalable but commercially fragile. The architecture meets the functional requirement and then collapses under the billing model because nobody designed the financial control plane with the same seriousness as the network. The fourth breakpoint is latency-sensitive and locality-bound systems. This is where pure public becomes dangerous, not just expensive. Clinical workflows, industrial systems, point of sale, plant floor integration, real-time fraud checks, always-on transaction systems where a few milliseconds become a contract term and retry later is not a business strategy. These environments punish distance. And when they punish distance, they punish your SLOs. Then SLO breaches become customer breaches. Then outages become legal problems. That distinction matters. And this is the moment to be explicit about who pure public Azure is risky for. Regulated industries with audit requirements, capital-intensive operations that can't tolerate volatility, and always-on transaction systems where downtime isn't an incident, it's revenue loss with a regulator watching. Here's the composite failure pattern. An organization moves a stable workload into Azure because the board demanded modernization. It's a billing success in month 1. Then usage normalizes. The workload doesn't scale down. The team adds redundancy. They add more monitoring. They add dev and staging environments, just like production. The invoice climbs. Then someone tries to fix cost by right-sizing. Performance dips. The business complains, so they scale back up. The bill returns. Nobody is happy. It's not because Azure is broken. It's because the workload is stable, and the organization tried to buy stability using a volatility-optimized platform without an explicit economic model. And there's a deeper trap here. When public cloud is the default answer, executives stop funding hard conversations. They stop funding application rationalization. They stop funding data placement analysis. They stop funding operating model redesign. They say move it to Azure and assume value will appear. Value doesn't appear. Systems behavior appears. So where does this leave you? Pure public Azure breaks when you need predictability more than optionality, when you can't tolerate latency, and when your governance can't keep pace with how fast teams can create resources. And the bills don't happen. They accumulate through behavior. Cloud economics reality. Bills are behavioral. Cloud economics is not mysterious. It's just uncomfortable because it turns your bill into a mirror. On-prem spend is mostly structural. You buy capacity, you amortize it, and you hide a lot of waste inside. We already paid for it. Public cloud spend is behavioral. Every environment someone forgot, every oversized SKU, every log pipeline nobody tuned, every backup policy set to forever, every cross-region data transfer that looked harmless in a diagram, those behaviors compound into a bill. And Azure doesn't bill you for intent. It bills you for reality. This is why cost optimization fails when it's treated as a cleanup project. If your organization thinks FinOps means a quarterly panic and a spreadsheet, you will never win. You'll just cycle, overspend, blame engineering, freeze projects, then overspend again. That's not governance, that's theater. FinOps in the adult form is an accountability loop. Visibility, allocation, and consequences, not punishment, consequences. Visibility means you can answer basic questions without a week of detective work: what environments exist, who owns them, and what business capability they serve. If you can't inventory your cloud estate accurately, you're not optimizing, you're guessing. Allocation means costs are attached to something real: a product, a team, a customer segment, a region. If spend is pooled into one big bucket, you've designed for denial. Nobody feels the impact of their decisions, therefore behavior doesn't change. And consequences means the organization has a response when behavior drifts. Automated shutdowns for dev environments, guardrails that prevent untagged resources, budgets that trigger investigation, and a platform team empowered to enforce intent. Not just advise, enforce. Because the default state of cloud is drift. Now, there's a subtle trap that shows up around year 2, and it's always the same pattern. In year 1, leaders ask, why is our bill high? In year 2, leaders ask, why is our bill unpredictable? And the answer is, because you bought a system optimized for optionality, then you never built the discipline required to manage optionality. That's what reservations and savings plans expose. Commitment discounts exist because the provider wants you to behave predictably. If your workloads are stable and your architecture is mature, commitments are rational. If your workloads are volatile or your organization changes direction every quarter, commitments are a tax on indecision. But either way, you have to pick a posture, pay for flexibility or trade flexibility for predictability. And you can't pretend to have both. That distinction matters because it forces executives to admit what kind of business they're running. A business that values speed and experimentation will tolerate variance. A business that values predictability and fixed margins will need tighter constraints and more deliberate placement. If leadership refuses to choose, the cloud will choose for them through invoices. There's another cost reality leaders consistently miss. Cloud costs are rarely too high in general. They're misaligned. You can spend a lot and still be efficient if spend maps cleanly to growth, more customers, more transactions, more revenue. You can also spend a moderate amount and be inefficient if it's mostly idle capacity and duplicated tooling. The number isn't the truth, the ratio is. So the mature question isn't how do we lower the bill, it's what is the bill buying? And that's where unit economics becomes the only argument that survives. Cost per transaction, cost per active user, cost per customer onboarded, cost per model inference. Pick the unit that reflects your business, then track it relentlessly. When teams know the unit cost is visible and owned, architecture stops being an aesthetic debate and becomes an economic one. This also changes how you talk about modernization. Modernization is not move to past in. Modernization is reduce unit cost while increasing capability. Sometimes past does that, sometimes it doesn't. Sometimes the cheapest move is deleting the workload entirely. The cloud is brutally honest about that option because it stops billing you when the thing no longer exists. And yes, that means deletion is a financial feature. So if you want a diagnostic that cuts through all the optimism and all the excuses, here it is. Do you know your cost per customer or only your total bill? Hybrid cloud reframed. distributed compute, centralized control. So now the pivot. Hybrid cloud is not cloud plus leftovers. That framing is how organizations justify drifting into it without taking responsibility for it. Hybrid, done intentionally, is the opposite. It's deliberate placement under constraint with a control plane that stays consistent enough to keep governance from decaying. That's the core reframe. Hybrid is distributed compute with centralized control. Compute and data live where they must, in plants, hospitals, branch sites, sovereign regions, legacy data centers, or specialized hosting environments. But identity policy, inventory, security posture, and lifecycle management stay centralized, or as centralized as your architecture can make them without lying, because the real goal of hybrid is not location, it's coherence. The system problem hybrid solves is this. Enterprises can't standardize reality, but they can standardize how reality is managed. And that difference is the only way to survive a decade of constraints without turning the platform team into a help desk for exceptions. This is where the control plane versus data plane distinction stops being academic. Your data plane is messy. It always is. It contains the physical world, legacy dependencies, and the things that didn't get a budget line item for modernization. Your control plane is where you decide whether that mess is visible, governable, and auditable, or whether it becomes a blind spot that slowly turns into risk. Hybrid succeeds when the control plane stays deterministic even while the data plane stays diverse. And the drivers that create real hybrid requirements are not negotiable. First, sovereignty and locality. If you operate in regulated markets, you will eventually be forced to make location explicit. Not because a provider can't meet compliance, but because regulators increasingly demand evidence where data lives, who can access it, and how you prove it. Hybrid gives you a placement model where locality is a design input, not an after-the-fact exception. Second, edge and OT/AT convergence. The closer you get to physical systems, manufacturing lines, clinical devices, logistics, retail, point of sale, the more cloud-only becomes a fantasy. Those environments require local compute for latency, resilience during WAN failures, and integration with networks that were never designed for constant dependency on a hyperscaler control plane. Third, data gravity. Not the buzzword version, the operational version. Data accumulates where it's created. Once it accumulates, it drags compute toward it. Hybrid isn't a compromise in that world. It's simply admitting that movement has cost, risk, and time. There's a composite scenario that makes this real. A manufacturing enterprise wants predictive maintenance. The models and analytics tooling live comfortably in Azure. But the inference needs to happen close to the machines, and the raw sensor data can't be streamed constantly to the cloud without creating both cost and failure modes. So they place inference locally, keep critical operations local, and still use a cloud control plane to manage identity, policy baselines, and security posture across sites. That is hybrid by design, local execution, centralized intent. Now, Azure's posture here is pretty clear, and it's not subtle. Azure is not trying to convince you that everything belongs in Azure. Azure is trying to convince you that Azure Resource Manager and the Azure governance stack should remain the control plane even when the workloads don't move. That's what hybrid actually means in Microsoft's world. Consistency of management surfaces, not a forklift of workloads. And this is why the right mental model isn't on-prem versus cloud. It's where does the control plane live and how far does it reach? Because centralized control gives you a few things that matter more than raw compute. It gives you uniform identity and access patterns. It gives you policy enforcement that doesn't depend on hero engineers remembering what the standard was. It gives you audit evidence that doesn't require manual archaeology. It gives you lifecycle management, patching, configuration baselines, and inventory at a scale where humans stop being the integration layer. But here's the anchor that makes hybrid work and also exposes why it fails. Hybrid succeeds when cloud stops pretending it's the center. The cloud is a control plane, not a location. If leadership keeps treating Azure like the destination and everything else like temporary baggage, the organization will never fund the hard work, standardizing governance, making locality decisions explicit, and designing for long-term operations across sites and providers. So hybrid isn't the failure of a cloud strategy. Hybrid is the real strategy. If you admit what the enterprise actually is, distributed, regulated, latency-bound, and constantly inheriting complexity. And that leads to the next failure mode, because hybrid doesn't collapse from compute. It collapses from governance erosion. The real hybrid failure mode, tooling fragmentation. Hybrid doesn't fail because the workloads are split. Hybrid fails because the truth is split. Tooling fragmentation is what turns a manageable, distributed estate into competing realities that drift away from each other until nobody can confidently answer basic questions. What exists? Who owns it? Is it compliant? Can we patch it? Can we recover it? And if we had an incident right now, which logs would we trust? In a pure public Azure world, at least the control plane is singular. You have one primary policy engine, one RBAC model, one inventory surface, one posture story. It can still be misused, but it's one set of levers. Hybrid multiplies levers. The first fracture is console multiplication. One team uses Azure Portal and Azure Policy. Another team uses VMware tooling or some legacy CMDB. Another team uses a vendor console for edge devices. Another team uses whatever the managed service provider exposes. Each tool has its own vocabulary, its own access model, its own definition of healthy, and its own blind spots. Over time, those tools don't converge, they diverge. And when tools diverge, you stop having a single operational reality. You have narratives. The security team thinks the estate is controlled because Azure Policy shows compliance for what it can see. Operations thinks the estate is stable because their monitoring covers what they manage. The platform team thinks governance is working because landing zones are standard. Meanwhile, a chunk of the environment sits in the gaps between those views, unpatched, unmonitored, and effectively unaudited. This is the uncomfortable truth. Every additional management surface is an entropy generator. It creates new pathways for drift, new exceptions, new role assignments, new logging gaps, and new places where temporary becomes permanent because nobody owns the cleanup across boundaries. The second fracture is policy inconsistency. Hybrid organizations often start with good intentions. We'll standardize, we'll enforce baselines, we'll treat identity and policy as first class. And then reality arrives. The factory network can't support the agent. The legacy OS can't run the extension. The vendor appliance doesn't integrate. The region has sovereignty restrictions. So you create exceptions. One exception becomes a pattern. Then the patterns conflict. This is how deterministic security models turn probabilistic. The policy says deny public endpoints, but an exception exists just for this one integration. The policy says MFA for admins, but break glass accounts live in a different identity boundary. The policy says log everything, but some locations can't forward logs consistently, so you accept partial telemetry. At first, those are conscious trade-offs. Then staff changes, the exception becomes institutionalized. Nobody remembers why it exists, but removing it feels risky, therefore it stays. That is how compliance erodes, without anyone making a bad decision. Compliance doesn't disappear, it becomes conditional. That's conditional chaos. A system where security and governance depend on context, tribal knowledge, and the right people being awake. The third fracture is split brain operations: patching, logging, incident response, change control, backup, key management. Each of those functions starts to differ by location and vendor, not because teams want it, because each platform nudges you toward its own default operating model. Azure Update Manager here, some legacy patch tool there, Azure Monitor here, a third-party APM there, Defender for Cloud Posture here, a different CSPM elsewhere, different alert formats, different escalation paths, different runbooks. When incidents happen in that world, engineers spend the first hour negotiating reality. Is this an Azure issue, a network issue, an on-prem issue, a vendor issue, or an identity issue? The system doesn't answer. Humans do, and humans are slow, especially when they are busy arguing about whose dashboard is authoritative. This is why hybrid often produces a specific organizational smell. Platform teams become human middleware. They translate between consoles, they chase exceptions, they reconcile inventories, they explain to auditors why one environment has evidence and another has screenshots. They are the glue holding together incompatible control planes that should never have been allowed to fragment in the first place. And once platform teams become middleware, delivery slows, burnout climbs, and shadow IT returns because teams will route around friction long before they route around risk. So if you want the practical definition of a failed hybrid model, it's simple. It's not we have workloads on-prem and in Azure. It's we can't enforce intent consistently across where we run. And the only sustainable response is to collapse management surfaces, not multiply them. You need a control plane that projects outward, standardizes inventory, standardizes policy, and gives you one set of levers to express intent. Because hybrid compute is survivable. Hybrid governance without enforcement is not. Azure Arc explained, like an adult, a control plane projection. So this is the point where most conversations collapse into product names and screenshots. Azure Arc is not interesting as a product, it's interesting as an architectural move. Azure Arc is Microsoft projecting Azure Resource Manager outward, past the Azure boundary so the control plane can see and govern things you didn't or can't move. Servers in your data center, Kubernetes clusters you run yourself, machines in other clouds, sometimes data services, sometimes edge. In plain terms, Arc turns some random machine over there into an Azure-managed resource with an identity, tags, policy evaluation, and a place in your inventory graph. That distinction matters because the core problem in hybrid isn't that compute is distributed. The core problem is that management is fragmented. Arc is Microsoft's attempt to collapse those fragmented management surfaces back into a single control plane posture. And yes, that is a strategic dependency. Arc doesn't make you cloud agnostic. It makes you governance consistent by anchoring governance in Azure. If you accept that trade, The payoff is obvious. One RBAC model to express who can do what, one policy engine to express what is allowed, and one inventory surface to answer what exists without begging 10 teams for spreadsheets. Now let's get precise about what Arc actually is. At the center of Azure governance is Azure Resource Manager. ARM is the control plane API layer that sits behind the portal, the CLI, templates, policy evaluation, RBAC enforcement, the whole thing. Per Microsoft's own architecture, when you create or configure resources in Azure, you are interacting with ARM. Arc extends that management layer to resources outside Azure. That's why the right mental model isn't Arc is a hybrid product. The right mental model is Arc is an onboarding mechanism into ARM. Once something is onboarded, you can apply the same governance constructs you already use in Azure. Tags, policy assignments, role assignments, monitoring integrations, posture management, update management, and, in some scenarios, configuration baselines. And Arc is explicit about what it governs. First, servers, Windows and Linux machines, physical or virtual, running in your data center or in other clouds. Those become Arc-enabled servers represented as resources in Azure. Second, Kubernetes clusters. If you've got a CNCF conformant cluster on-prem or in another cloud, Arc can connect it and let you apply governance and GitOps-style configuration patterns through Azure's management surface. Third, in some cases, data services. Azure Arc-enabled data services exist to run certain Azure-managed data offerings on Kubernetes outside Azure. That's not a free lunch. It's Azure's operating model running on your hardware with your constraints. Now, what Arc is not. Arc is not Azure Stack. It is not a hardware appliance. It is not we brought Azure into your data center. Azure Stack is about bringing Azure services locally. Arc is about bringing Azure governance and management locally. Arc is also not multi-cloud neutrality theater. It does not erase provider differences. It does not make AWS policies equal Azure policies. It doesn't eliminate network design. It doesn't remove latency. It doesn't delete regulatory constraints. It does not make your estate portable. It makes your estate visible and governable through Azure. That's the whole bet. Which leads to why this matters. Arc's value is governance, not compute. When an auditor asks, show me what systems exist, who can access them, and whether they meet baseline controls, the problem is not that the workloads are scattered. The problem is that the evidence is scattered. Arc tries to consolidate evidence because it consolidates inventory and policy evaluation into one place. When security asks, where are our unpatched servers, the problem is not that patching is hard. The problem is that the patching responsibility is fragmented across tools and teams. Arc tries to unify that lifecycle capability. When platform teams get tired of being human middleware, Arc is the architectural attempt to stop requiring translation between consoles. Now the credibility sentence, because adults acknowledge trade-offs. Arc adds dependency on Azure's control plane. It requires skills to operate correctly. And it does not fix bad operating models. If your organization can't own identity cleanly, Arc won't save you. If you can't define policy intent, Arc will enforce confusion faster. And if you treat onboarding as we connected it, we're done, drift will return because Arc is a control plane projection, not a discipline replacement. But if you actually want hybrid to be governable, Arc is the most honest move Microsoft has made in years, not more clouds. One control plane extended outward. Arc in practice, governance, security, and lifecycle at scale. Once Arc is onboarded, the interesting part starts. You're no longer managing a bunch of machines. You're managing an estate as a governed graph. That changes how leaders should think about hybrid operations because the question stops being where do we run it and becomes can we enforce intent consistently across where we run it. The first practical win is unified governance patterns. Arc gives you one place to express standards, tags, RBAC, and policy assignments that apply to resources that used to live outside your line of sight. That doesn't magically solve cross-cloud identity differences, but it does give you a consistent governance surface where you can at least say, these classes of machines must meet these baselines, and here is the evidence. In other words, governance becomes an engine, not a committee. The second win is posture management becoming the default expectation, not an annual audit scramble. Enterprises often treat compliance as an event, a deadline, a point-in-time story they tell auditors with screenshots and heroic effort. That model dies in hybrid because the estate is too distributed and the drift is too constant. Arc pushes you toward continuous posture, policy evaluations, inventory queries, and security signals that update as the environment changes. That distinction matters because continuous posture is the only thing that scales in regulated environments. If you can't prove controls continuously, you're not compliant, you're just lucky between audits. Third, drift control. This is where Arc becomes either transformative or useless, depending on whether you treat desired state as real. Arc doesn't stop drift by existing. It gives you the machinery to measure drift and, in some cases, enforce correction. Policies can audit, some policies can remediate, machine configuration can evaluate OS-level baselines, and for Kubernetes, GitOps becomes the most rational way to reduce entropy. Declare the desired configuration once, then let the cluster reconcile itself back to that state. That's the adult trade. You replace "did someone remember to do the thing" with "the system pulls itself back into compliance." The fourth capability is observability as governance, not just operations. Most enterprises still treat monitoring as "is it up?" That's a low bar and it's irrelevant during an audit or an incident. What matters is, can you trace a change to an outcome, and can you prove the system behaved within its controls? Arc-connected resources can feed into centralized monitoring and logging patterns. Not because logs are exciting, but because logs are evidence. Without unified telemetry, your security model becomes probabilistic. You cannot secure what you cannot see, and you cannot prove what you cannot query. And yes, this is where people discover that their logging strategy is actually a handful of agents installed inconsistently over the last 5 years. Arc turns that inconsistency into a visible defect, which is exactly what you want, even if it's embarrassing. Now, the lifecycle part that executives underestimate: patching and configuration at scale. Hybrid estates fail slowly. They fail through unpatched servers, forgotten images, unsupported runtimes, and exceptions that never got revisited. Arc doesn't magically patch everything, but it gives you a unified inventory of what needs patching and a governance pathway to make patch compliance measurable. Once patching is measurable, it can be operationalized. Once it's operationalized, it stops being hero work. That's the whole point: reduce the number of problems that require heroics. Here's the composite scenario where Arc actually pays for itself. A regulated enterprise runs workloads in Azure, in a private data center, and in another cloud inherited via acquisition. Prior to Arc, the audit process is basically a reconciliation exercise. Pull exports from 3 consoles, normalize them manually, argue about which one is correct, then hope the auditor accepts the narrative. After Arc, at least the inventory and governance posture can be expressed from one control plane. You can query what exists, assign baselines by scope, and demonstrate compliance drift over time with evidence that isn't handcrafted. It won't eliminate all audit pain, but it converts audit as archaeology into audit as reporting. And this is the critical operational payoff. Platform teams stop being translators. They stop spending their lives mapping AWS terminology to Azure terminology to on-prem terminology while incidents burn. They get a single place to express governance intent and a single place to retrieve reality, but keep the credibility intact. Arc has limits. It doesn't remove latency. It doesn't unify every operational feature across every environment. It introduces a dependency on Azure's control plane. It requires disciplined identity design and policy hygiene. And it will absolutely expose your operating model debt, because the moment everything is visible, everyone can see how inconsistent the estate really is. That's not a downside. That's the bill coming due. The practical outcome, if you do this right, is simple. You reduce hybrid entropy by collapsing management surfaces and making drift measurable. And once drift is measurable, it becomes governable. Now, here's the part nobody likes hearing. If Arc reduces hybrid entropy, multi-cloud multiplies it. Multi-cloud, strategy, insurance policy, or inherited damage. So now we get to the architecture everyone wants to talk about because it sounds sophisticated. Multi-cloud. Most organizations describe it as strategy. Some describe it as resilience. Procurement describes it as leverage. Engineers describe it as pain. All of those can be true. But the first question is the only one that matters. Are you choosing multi-cloud or are you inheriting it? Because the honest version of enterprise reality is this. Multi-cloud usually arrives the same way hybrid does. One constraint at a time, one acquisition at a time, one SaaS decision at a time, one "we needed it yesterday" decision that never gets revisited. And the organization calls the result architecture because calling it accumulated decisions sounds less impressive. This is the uncomfortable truth. Most multi-cloud is not a designed system. It's a stitched ecosystem. Now, there are legitimate reasons to do it. Regulatory separation is one. Sometimes you need a hard boundary between jurisdictions, business units, or data classifications. And the cleanest boundary you can buy is a provider boundary. Not because the provider is magically more secure, but because the control plane and the operational blast radius are different. Risk isolation is another. Some leaders want a second provider as an insurance policy against outages, geopolitical risk, contract disputes, or a provider making a platform change you can't absorb quickly. That's not irrational. But insurance policies have premiums, and the premium in multi-cloud is always paid in operations. Then there's specialized capability. One provider has the service you need in the region you need with the certifications you need. That's normal. The myth is thinking you can take that one workload, place it in another cloud, and keep everything else unchanged. You never do. Identity, logging, key management, networking, monitoring, deployment pipelines, those all have to reach across boundaries or split into separate stacks, which means every special case becomes a structural decision. And then there's the driver nobody wants to admit is dominant, M&A. You buy a company, you inherit their cloud. You don't get to vote. You get a new identity boundary, a new logging stack, a new network model, and a pile of operational debt that already works well enough that nobody will let you touch it in the first 12 months. So multi-cloud becomes the price of growth. And the platform team becomes the thing that makes growth survivable, This is where executives usually ask the wrong question. They ask, can we standardize providers? The right question is, can we standardize governance? Because procurement leverage is not operational leverage. That distinction matters. Procurement leverage is negotiating discounts, contract terms, and renewal options. Operational leverage is being able to run the system with predictable outcomes. Consistent access control, consistent visibility, consistent incident response, consistent compliance evidence. Those are not the same lever. One reduces invoice risk, the other reduces existential risk. And multi-cloud increases existential risk unless you deliberately invest in a unifying operating model. Here's the hidden tax that shows up every time. Skills don't generalize cleanly across clouds. Identity models are similar in concept and different in execution. Logging and telemetry are never identical. Network primitives differ, policy engines differ. Even when you standardize on Kubernetes, you still have 2 or 3 ways to do load balancing, ingress, secrets, and upgrades, plus the provider-specific edges you end up needing anyway. So the organization pays twice, once in tool sprawl and again in cognitive load. Then come the real costs that don't show up on an Azure invoice: coordination tax, incident tax, audit tax, and burnout. Multi-cloud often creates a platform team that becomes a survival function, not a center of excellence. A survival function. They build the cross-cloud identity patterns, they normalize logs, they create shared deployment practices, they arbitrate exceptions, they become the people everyone calls when something crosses a boundary and stops behaving like a single system. And this is where the multi-cloud for leverage narrative usually collapses. If you need to run 2 clouds to threaten 1 cloud, but the operational overhead of 2 clouds costs you more than the discount you might negotiate, you didn't gain leverage. You bought complexity. So the mature executive posture is not multi-cloud is good or multi-cloud is bad. It's asking what you are actually buying. Are you buying capability that can't exist any other way? Are you buying risk isolation you can operate during a real incident? Or are you buying inherited damage and calling it choice? Because if it's inherited, the goal is not to celebrate it. The goal is to contain it with governance, inventory, and consistent control planes. Otherwise, it spreads. And once multi-cloud spreads, the failure mode isn't, we have 2 providers. The failure mode is distributed systems reality, latency, resilience, event chaos, observability gaps. That's next. Multi-cloud engineering realities, latency, resilience, event chaos. Multi-cloud becomes real the moment your architecture crosses a boundary and still has to behave like one system, not connected, behave. And the first thing you pay is latency, not theoretical latency. The kind that shows up as timeouts, queue backlogs, and users saying it's slow while every dashboard claims green. Cross-cloud latency is not solved by optimism. Private connectivity helps, express route, direct connect, interconnects, all of that. But the link is only the beginning. Your code still has assumptions baked into it. Default timeouts, synchronous calls, where nobody measured round-trip time, retries that were safe in one environment and catastrophic across a boundary. This is where the uncomfortable rule shows up. Once you cross cloud boundaries, you are no longer engineering a cloud app. You are engineering a distributed system. That distinction matters because distributed systems don't fail politely. They fail with partial truth. One side sees the request, the other side didn't. Your client retries. Now you have duplicates. Or worse, you have state changes you can't easily reason about because you lost a clean, single timeline, which leads directly to resilience. Most teams confuse resilience with uptime. They build active-active diagrams, talk about multi-region, and assume the system is highly available. But resilience is not just surviving the outage. Resilience is recovering correctly after the outage. In multi-cloud, that means you need replay, reconciliation, and idempotency by design. If an event stream crosses boundaries and one provider has a brownout, you need the system to hold the events, replay them, and converge to the correct state when things return. Without that, you don't just get downtime, you get data inconsistency. And in financial services, healthcare, and regulated operations, inconsistent data is an incident even when everything is up. Here's the weird part. The more you add retries to increase reliability, the more likely you are to amplify failure. Retry storms are how small network issues become full outages, especially when 2 clouds disagree about what's failing. One side sees slow responses, retries harder. The other side sees load spike, slows further. Congratulations, you invented cascading failure with extra steps. So you need circuit breakers, you need back pressure, you need queues that can absorb shock, and you need your system to degrade intentionally when cross-cloud dependencies misbehave instead of pretending everything is fine until it collapses. Now the part most multi-cloud programs stumble over, event ordering and consistency. In a single environment, people assume a nice linear timeline. It's already a lie, but it's an easier lie. In multi-cloud, the lie breaks immediately. Events arrive out of order, clocks drift, network paths vary, consumers process at different speeds. The same transaction can be approved in one place, while another place still thinks the fraud check hasn't happened yet. So you have to choose your consistency models. Strong consistency across clouds is expensive and often impractical. Eventual consistency is survivable, but only if you design the business process around it. sequence numbers, idempotent handlers, deferred processing, reconciliation jobs, and explicit, this may take a moment behavior in user flows. If you don't make that explicit, your system will still be eventually consistent. It will just be eventually wrong. And that takes us to observability, which is where multi-cloud becomes either manageable or unfixable. In a multi-cloud incident, local logs are not enough. You need end-to-end traces across boundaries. You need correlated IDs that survive hops. You need to see one transaction's journey through multiple services, multiple queues, multiple providers, and multiple identity decisions. Without that, you are blind. And blind systems don't get debugged, and they get rebooted until the symptoms stop and the root cause becomes folklore. This is why multi-cloud turns incidents into systems behavior. The system is behaving exactly as designed, independently, asynchronously, and without your human desire for linear explanations. So if leadership wants multi-cloud, they are also choosing to fund distributed systems engineering, explicit latency budgets, deliberate resilience patterns, event replay, idempotency, and unified observability. Otherwise, they're not building redundancy, they're building conditional chaos across providers. When multi-cloud works versus when it becomes self-inflicted pain. So when does multi-cloud actually work? Not survive, work. Delivering a real advantage that justifies the tax you're choosing to pay. It works when the reason is explicit, durable, and tied to constraints you can't negotiate away. Regulatory separation is the cleanest example. If one dataset must stay in one jurisdiction and another must not share control planes, you can either build a complicated internal segmentation model or you can use a provider boundary as an enforcement mechanism. That can be rational, but you still have to operate it. The boundary gives you isolation, it does not give you coherence. Risk isolation can also be valid, but only if you treat it like an insurance policy with drills. If leadership says we're multi-cloud for resilience, then leadership is also saying we will fund multi-region and cross-cloud failover testing, and we will accept that some architectures will be duplicated. If you don't test failover, you don't have resilience. You have two builds. Best of breed can work too, but only when you constrain it. One cloud for a specific workload class, a defined integration surface, a defined identity model, a defined logging model, and a platform team that can enforce those definitions without exceptions becoming the default. That's the meta rule. Multi-cloud works when it is bounded. Now let's talk about the scenarios that fail, because they fail far more predictably than the success cases. The first failure mode is portability theater. This is where executives say, we want to avoid lock-in, and engineers interpret that as never use any managed service deeply. So you end up rebuilding cloud services yourself, databases behind Kubernetes, DIY messaging layers, bespoke observability pipelines, a homegrown platform that resembles a hyperscaler, but without hyperscaler staffing. You didn't avoid lock-in, you just locked yourself into your own mediocre implementation, and you paid for it with delivery speed. The second failure mode is duplicated toolchains. Teams run one CI/CD model in Azure DevOps, another in GitHub, another in a third-party system, one logging stack in one cloud, another in the other cloud. Different secret stores, different network patterns, different identity assumptions, different incident processes, different audit evidence. At that point, multi-cloud isn't an architecture. It's parallel companies sharing a logo. And the third failure mode is fractured identity and policy. Identity is the backbone of control. Policy is the expression of intent. In multi-cloud, identity fractures faster than anything else because each provider has a different grammar for roles, scopes, and enforcement. So what happens? People take shortcuts. They create broad roles temporarily. They reuse service principles for convenience. They store credentials where they shouldn't. They accept gaps in conditional access because that's only for Azure. They run separate break glass patterns in each environment. They end up with 3 different definitions of privileged access. And then they tell themselves the system is secure because each environment has security tooling. That's not security, that's distributed hope. So here's the hard rule, and it's not negotiable. Multi-cloud succeeds operationally only when governance precedes portability. Governance first means identity model first, logging and telemetry first, policy enforcement first, inventory first, incident response first. The control plane posture is designed before the portability story is sold, because portability without governance is just moving problems faster. This is also why procurement leverage is a distraction. Procurement cares about replacing vendors. Operations cares about surviving complexity. If you can't operate the system, you can't exploit your options. You become dependent on the very thing you claimed you were avoiding. The specific people who understand the cross-cloud mess. That is not resilience, that is key person risk at cloud scale. Here's the composite failure archetype that shows up in tech-forward enterprises. They decide multi-cloud is their identity. They invest in cloud-agnostic everything. They create platforms to abstract providers. They distribute workloads for theoretical flexibility. And then delivery slows, security gets inconsistent. Incidents take longer because nobody can see end-to-end. The platform team becomes the bottleneck because every decision crosses boundaries. Eventually, leadership asks why velocity dropped. And the answer is simple. They optimized for optionality, then forgot that optionality has operating costs. Now, to be clear, none of this says multi-cloud is wrong. What it says is unmanaged operating models are wrong. Multi-cloud can be a rational response to constraints. But if you treat it as an aesthetic preference or a procurement tactic, it becomes self-inflicted pain. So the decision isn't how many clouds do we want. The decision is how much complexity can we operate without losing control, and how much governance discipline are we willing to enforce to keep that complexity from decaying. The 5-axis decision framework leaders can actually use. So at this point, the temptation is to say, it depends, and go back to arguing about providers. That's the comfortable failure mode. Instead, this is the part where leaders take ownership of the constraints they've been pretending are optional. Architecture isn't a vibe. It's a set of trade-offs you'll pay for every day, for years. So here's a decision framework that's blunt enough to survive an executive room and simple enough to run without turning it into a 6-month analysis project. 5 axes, score each one from 1 to 5, low to high. And yes, this is runnable in a single 90-minute session if the right people are actually in the room. The security lead, the platform or infrastructure lead, the application lead, finance or procurement, and one business owner who can say what failure costs in real terms. Axis 1, regulatory pressure. A score of 1 means regulation is light and mostly internal policy. A score of 5 means you operate under real external scrutiny. Audits, evidence requirements, residency constraints, and consequences that involve more than embarrassment. High regulatory pressure pushes you away from public only by default, not because public cloud can't be compliant, but because the operating model has to produce evidence continuously. If you can't prove control, you don't have control. Axis 2, latency sensitivity. A 1 means humans won't notice if you add 50 milliseconds. A 5 means latency is contractual or safety related. Clinical systems, industrial control, point of sale, real-time fraud decisions, anything where a bit slower turns into we are down. High latency sensitivity pushes you toward hybrid placement, edge execution, and architectures that don't depend on cross-cloud round trips for critical paths. Physics will win. It always does. Axis 3, cost predictability requirements. A1 means the business tolerates variance because growth and speed matter more than precision. A 5 means margins are tight, forecasting matters, and leadership will punish unpredictability harder than it punishes delay. High predictability requirements don't automatically mean no public cloud. They mean you need commitments, governance, unit economics, and guardrails that are enforced, because optionality without discipline turns into invoice volatility. Axis 4, internal cloud maturity. A1 means you don't have a real platform model. Weak tagging, inconsistent identity controls, ad hoc networking, minimal policy enforcement, limited observability. A 5 means cloud is an operating model you actually run. Infrastructure as code is normal, policy and RBAC are consistent, cost allocation works, and teams can ship without bypassing governance. This axis is the maturity mirror. Low maturity doesn't mean you can't use cloud. It means the architecture you choose will degrade fast. Multi-cloud in a low maturity org isn't advanced. It's self-harm with a roadmap. Axis 5, change velocity. A 1 means the business changes slowly, releases are infrequent, the environment is stable. A 5 means constant iteration, new features, new markets, frequent deployments, rapid experimentation. High change velocity favors public first and managed services because the organization needs speed and can justify paying for elasticity and platform capabilities. Low change velocity favors predictability and deliberate placement because always on and rarely changed behave like a steady state system. Now, once you score these 5 axes, you don't get a single answer. You get a gravity field, but the outputs tend to cluster into 4 categories. Category 1, public first by design. This is low to moderate regulatory pressure, low latency sensitivity, high change velocity, and at least moderate cloud maturity. Cost predictability can vary, but only if you've built real FinOps governance. Public first works here because the business is paying for speed and can operate the platform. Category 2, hybrid first by design. This is high regulatory pressure and or high latency sensitivity with a real need to keep some data and compute local. Hybrid first succeeds when you treat Azure as the control plane and accept that locality is a constraint, not a failure. This is also where Arc stops being optional because centralized governance is what prevents hybrid from decaying into tool sprawl. Category 3, multi-cloud by accident. This is the common enterprise pattern. You already have multiple providers due to acquisitions, regional constraints, SaaS sprawl, or historical decisions. The goal here is not to celebrate it, the goal is to contain it. Standardize identity posture, logging, and policy as much as possible, and stop pretending portability will save you. Category 4, multi-cloud by design. This is rare. It requires high cloud maturity and explicit reasons that justify the tax, hard regulatory separation, true risk isolation with tested failover, or specialized workload requirements. And it only works when governance precedes portability. So here's the worksheet prompt that makes this practical. What must stay local? What must scale globally? Where does governance break today? And what complexity are you already owning without admitting it? If leadership can answer those honestly, the right architecture usually becomes obvious. The organizational cost nobody budgets for. Once you pick a model, public first, hybrid first, or multi-cloud, you don't just pick technology. You pick an organizational tax structure, and nobody budgets for it. The first cost is talent burn, because complexity doesn't disappear. It relocates into the platform team. When identity differs by environment, policies drift by location, and tooling multiplies, platform engineers become human middleware, translating intent into 5 different systems, chasing exceptions, and cleaning up after every just this once. That job doesn't scale, it accumulates fatigue. Then the best people leave, and the architecture becomes even more fragile, because now the only thing holding it together was institutional memory. Multi-cloud loves to create key person risk, hybrid loves to create exception handlers, public cloud loves to create sprawl. Pick your poison. The second cost is decision paralysis. When governance is weak, every decision becomes negotiable. Standards turn into suggestions. Suggestions turn into exceptions. Exceptions turn into how we do it now. Over time, the organization stops arguing about what's correct and starts arguing about what's allowed, because policy isn't enforced by design, it's enforced by meetings. That is not an operating model. That is slow motion entropy. The third cost is shadow IT returning, because friction always creates bypass behavior. If it takes weeks to get a resource approved, teams will buy SaaS with a credit card. If the platform team says no without offering a safe path, teams will root around them. Not because they're malicious, because delivery pressure is real and incentives beat policy. And the moment you have shadow IT, you don't have a cloud strategy. You have an audit problem waiting for a date. The fourth cost is security drift. Security doesn't fail as a single event. It erodes through accumulated exceptions, unowned resources, inconsistent logging, and identity sprawl. The longer the environment exists, the less deterministic your control becomes, unless you actively fight drift with policy enforcement, inventory discipline, and consistent lifecycle management. This is why we're secure is never a statement. It's a continuously re-earned condition. And this is the quiet advantage Azure often has in real enterprises. Control plane consistency reduces coordination tax. Not because Azure is magic, but because when one governance stack can reach more of your estate, you spend less time reconciling reality across silos. But don't confuse that with a vendor win. It's an operating model win, because the true cost of cloud isn't the build. It's the complexity you didn't assign an owner to, the policies you didn't enforce, and the humans you burned out to keep the system coherent. The question you should leave the room arguing about, choosing public, hybrid, or multi-cloud, is choosing how much control and complexity you'll own for the next decade and who pays for it. If you want the follow-up, listen to the next episode on building a control plane that survives policy drift and organizational entropy, because the winners won't be the ones with the best cloud, they'll be the ones who can operate complexity without losing control.